Hi National 5, welcome to lesson 3. So as usual we're going to have a wee starter. So we've got 4 questions. First question, in terms of hydroxide ion concentration and pH, what happens to the alkali sodium hydroxide as it is diluted? Okay, so what happens in terms of pH and hydroxide ion concentration, what happens to it? Question 2, starting with carbon, explain how this could lead to contributing towards acid rain. Question 3, name the 3 common acids and give their formula. Question 4, why does the non-metal oxide silicon dioxide not form an acid solution? I'll change that, not form an acidic solution when added to water. Okay, so as usual, pause the video, do the questions. Once you've done them, unpause it and I'm about to go through it. So question 1, sodium hydroxide is an alkali, so it's got a pH greater than 7. Okay, so if we dilute that, okay, the pH will decrease. Remember what I said, you have to say this bit, it will decrease towards pH 7. Okay, so you're talking alkalis anything above pH 7, so probably about 14 for sodium hydroxide. We dilute it, it decreases towards 7. Okay, and the hydroxide ion concentration will decrease. Okay, remember alkalis have more hydroxide ions than hydrogen ions, so if we dilute it, we're going to decrease the number of hydroxide ions. Now, starting with carbon, explain how this could lead to contributing towards acid rain. So if we start with carbon, what we can do is we can burn it, and remember, anything we burn, we're burning it in oxygen, and that's going to give us carbon dioxide. Okay, and then what we do is we take that carbon dioxide, and what that can do is that can dissolve into the water when it starts to rain. Okay, and remember, as long as it's soluble, which carbon dioxide is, you will get an acidic solution. Okay, so CO2 dissolves in atmosphere when it rains, therefore rain is acidic. Okay, and that's where the term acid rain comes from. Okay, remember, any non-metal that we burn in oxygen gives us a non-metal oxide, and any non-metal oxide that dissolves in water will produce an acidic solution. Right, question 3, name the 3 common acids. Now, the first one, probably the easiest one, hydrochloric acid, and that's got the formula HCl. Second one is sulfuric acid, and that's got the formula H2SO4. And the third and final one is nitric acid, and that has the formula HNO3. Okay, you need to know that, you need to know the name, and you need to know the formula, so please make sure you've got that memorised. And then question 4, why does the non-metal oxide silicon dioxide not form an acidic solution when added to water? It is a non-metal oxide, so you would expect it to form an acidic solution, but the reason it doesn't is silicon dioxide is, is insoluble in water. Okay, it doesn't dissolve in water, and if it doesn't dissolve, remember all the way back to lesson 1, if it doesn't dissolve, the pH remains the same. So in this case, it would remain pH 7 because that's the pH of water. Okay, right. What we're going to do for lesson 3, I will make that clearer. This is our heading, bases and alkalis. Okay, lesson 3. Right, so we've been speaking about bases and alkalis, but we haven't, and I have mentioned it in previous videos, but I haven't written down a definition just to make it a wee bit clearer for us, so we're going to do that now. So, anything that can be used to neutralize an acid is called a base. Okay, now what we mean by neutralize is when we add a base to an acid and it gives us a neutral product. Yeah, and you would have learned from second year that those neutral products are salt plus water, but don't worry, we'll come back onto neutralisation in a future lesson. Okay, so anything that can be used to neutralise an acid is called a base. Okay, you need to know that. Now, where bases and alkalis differ, okay, is this bit here. So, if a base is soluble in water, then it is an alkaline. Okay, and that's important. So if we can dissolve a base in water, then it's an alkaline. So a wee note, all alkalis are bases. Yeah, so all alkalis are bases, but not all bases are alkalis. Yeah, so if you think about it, sorry, that's my front door, just ignore that, and my dog. If you look at it like this, okay, so if we call this circle all the bases, okay, now there's a subsection of that called the alkalis, yeah, and they're the ones that are soluble. Okay, so every single alkali is a base, but not every base is an alkaline. Okay, and that can be quite tricky to get your head around, but hopefully that makes sense. Now, there are three types of bases, and you're going to need to know them, and we will look at each one in a lot more detail again in future lessons. So the first one is going to be metal oxides. Second one is metal hydroxides. And the third one is called metal carbonates. Yeah? And these are also, they are, in fact, just ignore that. Okay, so there are three types of bases: metal oxides, metal hydroxides, and metal carbonates. Make sure you know each one. Now, just remember, last lesson we spoke about non-metal oxides, okay? And non-metal oxides dissolve in water to form solutions of pH less than 7, okay? So if metal oxides, metal hydroxides, metal carbonates, if they dissolve in water, they'll form solutions of pH greater than 7, okay? They'll be alkalis. Okay, so we'll make a wee note there. If any of these three types of bases dissolve in water, then the solution will have a pH greater than, yeah, there's that symbol, greater than 7. Okay, so that's going to make it an alkali, which is pretty cool. Okay, so the next heading we're going to do, I'll take a new page. The next subheading we're going to use is making alkalis. Okay, so we can make alkalis by starting with a metal. Okay, so very similar that we make acids by starting with non-metals, we make alkalis by starting with metals. Okay, so let's do, so what we do, very similar, yeah, in fact pretty much identical. The only thing that changes is instead of this being a non-metal for acids, it's a metal. Okay, so metal, we burn it in oxygen and that gives us a metal oxide. Okay, so that's our first step. Now our second step is we take that metal oxide, okay, that we've created, we dissolve it in water, and what we actually get, only if, yeah, I'll maybe make the note there, okay, so if it is soluble, okay, so if the metal oxide is soluble in water, we will create a metal hydroxide, and that metal hydroxide is an alkali with a pH greater than 7. Okay, pretty cool. Now, wee side note, if we take that metal oxide, yeah, and it can't dissolve, okay, in water, it's what we call insoluble. So if it's insoluble, yeah, what that means is nothing's going to happen, okay, the metal oxide is going to remain the same. We are going to get a solution of pH equal to 7 because that's the pH of water, and that's it. Okay, that's it. And that leads us on to our, in fact, wait there, I'll maybe do a wee example. Okay, so making sodium hydroxide. Okay, so what we do is we take sodium, okay, because that's the metal, and we burn it and we get sodium oxide. Now, sodium oxide, you are going to trust me, you are just going to have to trust me with this. Sodium oxide is soluble in water, and I'll show you in a wee while just how I know that. So sodium oxide is soluble in water, so what we're going to get is we are going to get sodium hydroxide, and that's probably the most common base, or alkali in this case. So yeah, that's going to be an alkali. Yeah, remember it's also a base because sodium hydroxide can neutralise acids, but because it's soluble in water as well, it's also an alkali. Yeah, right. Now that leads on quite nicely to solubility. Okay, how do I know what metal oxides, what metal hydroxides, what metal carbonates are soluble in water? Okay, so to find out the solubility, use page 8 of the Nat 5 data book. Okay, so you should have your data book there already. Now it looks like this. Okay, now don't panic, that says page 21. I'm just using the higher data booklet, but it's the same. If you turn to page 8 in the Nat 5 data booklet, it'll look like the same. So this is the solubility of selected compounds in water. Now there's a wee key here. VS means it's very soluble in water. S just means it's soluble in water. I means it's insoluble, and if there's a dashed line, there's just no data on it. Okay. Now, if we look at this, if we go back to here, I told you sodium oxide was soluble in water. Now, if we go down our list of metals till we find sodium, yeah, and if we go along, yeah, bromide, carbonate, chloride, iodide, etc., till we find oxide, okay, so we've got sodium, go along to oxide, yeah, and you'll see that is very soluble. Okay, so that's why I know sodium oxide can act as an alkali, because it's very soluble in water. Okay, if we look at copper 2 oxide, yeah, that's insoluble, so it wouldn't be an alkali, but because it's a metal oxide, it's still a base. Okay, because all bases are metal oxides, metal hydroxides, and metal carbonates. Okay, so let's just do wee examples here. Yeah, calcium oxide. Yeah, if we use let's find calcium oxide. Yeah, calcium, go along to oxide. S means it's soluble. Okay, so calcium oxide is soluble in water, therefore is both a base and alkaline. Okay, that's number one. Number two, let's go for magnesium oxide. Let's find magnesium, go along, it's insoluble. Now, it wouldn't matter what base of magnesium it would be, whether it was magnesium oxide, magnesium hydroxide, or magnesium carbonate. They're all insoluble. Okay, so magnesium oxide is insoluble in water, therefore is only a base. Yeah? Now, number three, let me just pick one. Silver bromide. Yeah? Let's look at silver bromide. So there it is, silver bromide. It's insoluble. Okay? Is insoluble, but, okay, that's a big but. So silver bromide is insoluble, but is not a base. Okay? Now, why is it not a base? Because remember, if we go back to this page, there are only three types of bases: metal oxides, metal hydroxides, metal carbonates. Silver bromide is a metal bromide. Okay, so it's not a base. Yeah? It's not a metal oxide slash hydroxide slash carbonate. Yeah? Very important that. So what we're going to do, you know how much I like a summary. So we're going to summarise everything that we've learned about making acids and bases, okay, or alkalis, if it's soluble. So, non-metals and metals both burn, yeah, in oxygen, okay, O2 because it's diatomic. Non-metals and metals both burn in oxygen to form their respective oxide. Okay, so that's, if it's a non-metal that's burned, it's going to form a non-metal oxide. If it's a metal that's burned, it's going to form a metal oxide. Okay, now this is important, helps if I can spell. Soluble, okay, I'm going to highlight that, okay, because it has to be soluble. So soluble non-metal oxides form acidic solutions, and soluble, again I'll highlight that just now, soluble metal oxides, again that can be hydroxides as well, or it can be carbonates if you want. So soluble metal oxides, hydroxides and carbonates form alkaline solutions, okay? Anything with a pH above 7. Acidic solutions, pH greater than 7. Okay, now I was just going to highlight the word soluble, but it's important to probably highlight both of them. Yeah. If insoluble, pH remains 7 when added to water. Okay, and again that's worthy of a highlight. So that's what you need to know. So important that you know that. Yeah. These questions come up, time in, time out. Now, what we're going to do is we are going to do some questions together, and then I'm going to put up some questions in teams, and that's what you're going to do for the rest of the double. So, question 1. What will the likely pH of the following substances be when added to water? Okay, so what will the likely pH of the following substances be when added to water? Now I'm going to give you options. So it'll either be A, pH 5, B, pH 7, or C, pH 9. Okay, so we're going to look at A, zinc oxide, B, sulfur dioxide, C, silicon dioxide, and D, barium hydroxide. Okay, so you can pause the video, do the questions, and then see if you get the same answer as me. I will give you a hint though, you will need to use your data book for this. Okay, you will need to use your data book. Right, question 1A, zinc oxide. If we add that to water, so first things first, we need to get a data booklet. Page 8, yeah, remember this is a higher data booklet, so it's different, but page 8 of the NAT 5 data booklet. Now if we look at zinc oxide, we find zinc, we go along to oxide, it's insoluble. Okay, so because it's insoluble, that means it's going to have a pH of 7, so the answer is going to be B. Yeah? Now, sulfur dioxide, okay, you need to know that sulfur is a non-metal, yeah, it's found to the right of the stairs, so it's a non-metal, and that's a non-metal oxide, and you should know that sulfur dioxide, that's one of your acid rain gases, okay, sulfur dioxide, carbon dioxide, that's your acid rain gases, so that's going to form pH, our option there will be 5, so A is our answer. Okay, non-metal oxide, it's one of our acid rain gases, it has to be A because it's pH less than 7 and acidic solutions are. Silicon dioxide, okay, again, this is one you're going to need to know. Silicon dioxide, it is a non-metal oxide, yeah, so you'd think, oh, it's going to dissolve in water, it'll form an acidic solution, but remember, we spoke about this already, silicon dioxide is insoluble, yeah, it's a covalent network, so it's going to have a pH of 7, so the answer is B because it's insoluble. You need to know that, yeah. And then barium hydroxide, that's a metal hydroxide, so we can find this in our data booklets. So barium hydroxide is very soluble. Okay, so that there is very soluble. So what that means, it's going to dissolve in water, and because barium is a metal, yeah, it's in group 2, you would need to use the data booklet for that. Because it's a metal, remember our summary, soluble metal hydroxides form alkaline solutions. So out of our options, the only one that's an alkaline solution is 9. So it's going to be pH 9. So our answer is C. Okay? All about practice with these questions. Okay? All about practice. Right. Last question. Now again, a question like this, very common to come up. Yeah, so element X was burned in air, then then added to water. Okay. The solution made had a pH less than 7. What could X be? Okay, I'm going to give you 4 options. Is it A, tin? Is it B, zinc? Is it C, sulfur? Or is it D, sodium? Okay, so once you've written that, pause the video because I'm just about to go over the answer. Now, element X was burned in air. Okay, so obviously an oxide's been formed. Yeah? It was added to water. The solution had a pH less than 7. So this bit's important. This tells us that it's acidic. Okay? Now, you should know that acidic solutions are made from non-metal. Okay? Or should I say soluble non-metal oxides. Okay? So, the only non-metal there is sulfur. So the answer is C. Yeah? Again, sulfur would burn in air to form sulfur dioxide. Sulfur dioxide, that's an acid rain gas. It's going to form a solution less than 7, acidic. Yeah? Now tin, that would be tin oxide, zinc oxide, and then sodium oxide. They would, well, if we look at tin oxide, that's insoluble, so nothing would happen to the pH. Zinc oxide, nothing would happen to the pH. And sodium oxide is soluble, so that would make the pH, it would change the pH, but it would increase the pH to greater than 7. Okay, and that's how you work those questions out. So, what you need to take for today's lesson, from today's lesson, is that anything that can neutralise an acid is a base. If that base can dissolve in water, we can also call it an alkali. Yeah? You need to know your 3 main types of bases: metal oxides, metal hydroxides, metal carbonates. Yeah? You need to know how to make alkalis. Okay, so instead of taking non-metals, we take metals, we burn them to get a metal oxide. We'll take a metal oxide, we'll dissolve it in water, and if it's soluble, we'll get a metal hydroxide, and the pH is greater than 7. If it's not soluble, nothing happens to the pH, it remains 7. Okay, you need to know that. Data booklet, page 8, and you can find the solubility of all that. But yeah, that's your summary there. Okay, soluble non-metals, non-metal oxides form acidic solutions, soluble metal oxides form alkaline solutions. You need to know that. Okay, so I'm going to post up some working teams, but that's us for this YouTube lesson. Thank you.